Hi there, my name's Vince from My Mate Vince, and in this video today it's a trying to fix video. Emphasis on the trying. We might not actually be successful because in here we have another MacBook. So the MacBoominator is back in town. Will we blow it up or will we have a working one by the end of it? I'm not having much luck with these MacBooks. So in here we have one that was already sent to the Genius Bar over at Apple, and they quoted, are you sitting down? £607. So the i7 board was £483, the Touch ID bar thing was £55, and the labour to put it in was £69. £607. Whoa. Now apparently the keyboard and top case were replaced in June 21, but yet we have some serious scratches down here. I mean, that looks like a proper angry cat. What could have caused those deep scratches? But anyway, this is it here. I bought it on eBay for £350. The seller's been completely honest with everything. In fact, the seller has watched my other video on the 2020 MacBook. So, MacBook Air. Yeah, here it is. So let's plug it in and see what's happening. Apparently it's got no power whatsoever. Let's just turn it on there. Is it doing anything? No, it's not. Let's get the amp meter into it over on the blue mat and see what it's drawing. Should be an interesting one. Right, so we've got our little meter here. Let's plug it in and see what it's doing. Will it go up to 20 volts? 5 volts? No, okay. So you see it's not jumping up to 20 volts, it's staying at 5. Let's try the other ports. I'll just fast forward through these bits here. There's 4 ports on this, there's 2 more around here as well. Okay, that's stuck on 5 volts. Again, stuck on 5 volts, and the last one is 5 volts again. So it's not going to turn on, but I'm just hitting down the power button. Let's hold it down for 10 seconds. I'm sure that's not going to make any difference to this. Right, okay, so that hasn't changed that at all. Now let's just try Option, Command, right shift for 7 seconds. 1, 2, 3, 4, 5, 6, 7. And now the power button while still holding them down for another 7 seconds. Okay, so you can see it's not turning itself off or back on again. It's doing nothing. So the charger's not communicating with the chips on the inside to tell it to give it 20 volts, and it's not turning back on again. Right, let's get the back off it and see if we can see anything obvious. So we're using a little pentalope screwdriver to get into the back here. This one's slightly more awkward, takes a little bit more lifting up and sliding out than other MacBooks that I've worked on. Anyway, while I'm doing this, it's My Mate Vince Massive Time, and the members this month are kitdigital.com, Kip Hakes, Max Rokotansky, Having Fun Repairs, Ellensburg Amplifier Repair and Service, Will Michaelis, Chris Seal, Felipe at MrKeebs.com, King Kurd from Lowbook Auto Sales, DJVG, Robert from Timsy's Auto Air, Albert at www.faroutsounds.co.uk, Stuart Park, Ellis Garbett, and Pigsy. So big thanks to all you guys. Big thanks to everybody that makes these videos what they are, whether that be via comments, views, Patreon. It all helps. My God. Whoa, right, got there eventually. He says. Right, that was not easy. Okay, so it's these things here that clipped it into place. Okay, we're in anyway. Now, first things first, let's disconnect the battery. I'm going to be using a T4 for hopefully most of them. Right, that is the battery disconnected. Let's plug it in now and see if it's doing anything different. No. Right, I think we need to take this board out, and then in doing so, if something like the screen's put a fault on it, then it will eliminate that, you see. To be fair, it looks very clean, doesn't it? Can't see any signs of any problems anywhere. Looks nice. Right, let's get undoing everything. I'm just going to plug it in now that these two, the keyboard and that's been undone. No. Do you know what I'd love if Apple wanted all that money and it was just a capacitor that was shorted? I'd love this to be a short rather than the chip problem. Here we go, we're free. So we know that side looks okay. Let's spin it over this side and see if it looks okay. Right, I can't see anything wrong here at all. It all looks very nice. So I suppose what we have to do is we have to find out where PP bus is, the main one coming in here, and see what it is reading. Because these chips here, if it's these ones, there's two here, that might be one there, that might be one there. They should be communicating with the charger to tell it to put through 20 volts, and they're not. But maybe the chips are not getting the reading to tell it to, you know, to enable these chips. These are like the USB controller ones, USB-C. I suppose in a way it might be easier if there was a bit of water damage, because that could pinpoint you to the problem. Right, let me get the schematics up for this board. I need to find out what it is. Here we go. It is at 820-01041-07. Let's see what's going on with that. Right, you know what? I've written down the board and stuff, but before we jump straight to the schematics, let's get the connectors on here. Let's get the connectors on both sides, and then let's put power into it, and let's actually go across some of the power supplies. You see where we have these coils, these big inductors? Let's go across here and see if we have anything, because that might give us an indication about where the fault is. And in case anybody's interested, that's what we've got here, A1990 EMC3215. Actually, it was good to do this anyway, because just in case the screen or something like that was putting a fault on. Is it going to stay at that? Yes, it is. So it's still not jumping up to 20 volts. So that's our initial problem. Whether there's more or not, I don't know. Right, let's get a ground from here, and let's go across some of these power supplies. See if we have anything. So nothing there. Nothing there. Still nothing. We haven't got anything yet. No, nothing on the whole board. Did I do these? I wonder whether, let's go to ohms, I wonder whether we've got like a big short somewhere. 2 ohm short, that could be a short, or maybe this is for feeding the the CPU. Let's go on this side. That's okay. 32 is probably going to be okay. I suppose let's keep away from here because this is where the main chips are. Ah, now that looks like a short. How about this one here? I'd love it if it was a short and a capacitor. Now I've got to find out what that one is there, but look at that. There you go, 0.6 of an ohm, so that is basically a short. Yeah? On that one there, let's find out what that one's about. That's good. Right, okay. Anything else? No, that's okay. And that's okay. Seven ohms is probably fine. 8 ohms is probably fine. Well, do you know what? I'm kind of glad we did it without looking at the schematics to begin with. 3 ohms might well be fine. So I think when you're dealing with the main chips, because they run on such low voltage, then you're going to get low resistance. So for example, people might think that's a short because they go to continuity, but this will beep under 50 ohms, and look, you'd be like, oh, it's shorting, but it's not. It's designed to be like that. It's 3 ohms, but I don't think this one here is designed to be like that. So I'm going to bring up the schematics. Let's find out what that one there is for. Now remember, it's this one here, yeah? So I found the board view. I'm using Paul Daniel's software here, Flex Board View. Honestly, it's really good. Just the few times that I've used it so far, for me, it just makes everything so much easier. So I think if you were doing these, even if you were just doing one a month, one a week or something, I think it would be worth every penny. But anyway, this is it here. This inductor, this is the one that we've got the short on. So this side here is PP3V, so it's 3.3 volts, G3 hot. And then this one is also 3.3 volts, and then it goes on to something else. But anyway, if I right click on this and search, and then if I bring up this one here, this is the same chip I was looking at that I had water damage on my 2020 one. So if you have a look down here, can you see we've got the 5 volt and the 3.3 volt power supply, and the one that I'm dealing with the short at the moment is this one here, L7660. If I was to go back to here, you can see hover over there, L7660. So basically somewhere along here is being pulled to ground, I think. Now it could be through this chip here, because this chip will have grounds in it. For example, there's a ground at the bottom there. But remember at the beginning I said that it would be amazing if it was a capacitor. Well, look, it could be, because you see from here, it goes up here, through here. Look at all these capacitors. 1, 2, 3, 4, 5. We've got 6 capacitors here. I mean, ideally, I suppose what I'd need to do is take off the inductor and see if the short's coming from this way or this way. The problem is, look, we do have like this one here, which is going to be some kind of, I'm not sure what that one's going to be, but I don't think it's like a feedback. But yeah, that's the problem, you see. It can bypass that, can't it? But I suppose it would eliminate whether there was a short on these, you know, these ones going up here. I don't know. Do you know what I'm tempted to do? 3.3 volts is coming out of here. So could I not just solder on a wire here and pump maybe just 1 volt or 2 volts into that line with high amps, and just to see what gets warm? Imagine if one of these 6 here got warm. And they correspond to these ones on the board here. I'll show you properly when I get to the blue map. But basically we've got, the tantalum ones, we've got a bunch of them here, and then a couple nearer my thumb down here as well. I think I might go for voltage injection on this one here. Oh, do you know, I'd be so happy if it was a capacitor issue, just like a normal fault. Oh, I'd love that. Right, I am going to whack it onto, which side? I'm going to go onto, well, it doesn't make a difference anyway, it's going to go through the inductor, isn't it? Let's just whack it on here, I've got more room. So I'm just going to add a little bit of leaded solder to that. And I've got a massive wire, far too big, but it should be alright. It's not going to short on anything else there. Right, that is balanced, balanced on there. So I'm just going to set my bench power supply to 1 volt, and I'm going to turn up the amps massively. Right, so if you have a look here now, I've got it set to 1 volt there, but yet when I touch the leads together, can you see the amps go up to 8 amps? Yeah. So let's connect that to there. And now let's connect up this one to here. Let me just check the other side of the board, make sure there's nothing. No, that's fine to connect to. Right, we are drawing 1 volt at 5 amps. So you can see we've got a full short there, 6 amps going up. So surely that's going to generate some heat somewhere. So let's get the IPA, isopropyl alcohol, and let's go around some of the capacitors and see if we can find anything. Maybe even it might even show up on my hands by just feeling. I've gone to 0 volts, 1 second. I mean 0 amps, how come? Ah, my lead's come off. Right, let me, do you know what, I think I need to check this side more, so let me do it so that, let me do a better connection on there. Really, I suppose a smaller wire would be better, wouldn't it? Smaller wire will flex more, so it won't be inclined to just to snap off. Positive onto the inductor. Yep, 5 amps and growing. I can feel heat, I can feel heat, I can feel heat. But is it coming from this side or here? Doesn't feel burning hot though, it just feels hot. Can't determine where that's coming from. So we've got capacitors here, and also these two are on that same circuit. Well, I'll tell you what, let's zoom in, use the IPA, see if we can see if it's coming from a certain component. Right, well it's certainly not burning off there, is it? Okay, let's try the other side. This is unfortunate, it's not giving me anything. That is weird, it just seems to be in the board. Do you know what I mean? It doesn't seem to be coming from any place in particular. I mean, my crocodile clip's hotter than anything else. What does that suggest? In fact, it's starting to burn. That's starting to burn. I'm confused now. Why is this so hot? Because it's just the same as my lead shorting together, but why is it not? Why is it not the board? Why is the board not getting really, why is the component not getting really hot? I mean, there's no damage to the board here, do you know what I mean? It's not, it'd be different if it was burnt and then you think, well, all that power's going through to the ground. Oh, I went from being really confident now to not understanding what's going on. Okay, what we'll do is, let's take off that inductor and then that will tell us which way the fault is going. See, that component can't be putting it down to ground because it's not on a ground. So it has to be a capacitor or a chip. Right, let's see now which pad it's going to be shorted. Not that one. So it's the one going off to the capacitors, this one here. So it's not the one, I think that goes from, is that fed from the chip? I'm not too sure. Right, so now we know it's going away. So I need to look at the schematics again and find out what's going on. Or should we put heat in? Let's put heat in again. Let's put voltage injection on that pad here now and see what happens. The problem I've got is the heat's coming from the crocodile clip. So wherever the crocodile clip is putting heat into that part of the board. No, all that's happening is this is getting red hot now. Look at that. How can that? Why is that not showing up on the board? 1.5 volts at 10 amps. Right, I'm turning it off. That's burning hot, but nothing else. Nothing else is. What's going on? Okay, I don't know what to do. Okay, so I'm going to go through the power rails here, and you can see that it's labelled up down here as power aliases 1, and then there's also another page as well. So let's start on here with the PP bus G3 hot. So this should be 13.1 volts. So let's see if we've got this. So right click on that and then go down to the board view, and now you can see it comes up in all the places. So let's just pick a nice easy place that we can get to it. So we are working on so we've been working up here, so let's go on to this capacitor here and these ones here next to this connector. So that's a nice easy place to test. So bottom of that capacitor, 12.2, and over here we've got it there. It seems a little low, but I think when I did the other board as well it was slightly low. Maybe it's my power supply or something, but yeah, so we've definitely got the main voltage rail coming into it. Let's look at the next one. Right, the next one, PP bus HSCPU, again 13.1 volts, and if I go to here, they're all these ones here, all the tops of these capacitors. So let's try that. And there you go, 12.2 again. So we have got that rail there as well. So you can see what I'm doing now. I'm just going to be working through each of the rails. I think anything that's come from the G3 hot is probably going to be working, the 12 volt. I think it's when we get down to the 5 and the 3 volt, we're going to have problems. So probably not the 5 volt, maybe just a 3.3. I need to remember though that I have removed this coil. So obviously when we get to those readings, that power supply there isn't going to be generating that voltage properly. But yeah, I don't really know what else to do. I can't see, to me it looks like it's kind of shorted internally, but I can't see how that would have happened. This board looks absolutely perfect. It's not bent or anything like that. So yeah, I don't think that's happened. Hopefully it will become clear as we start going through the power rails. Right, I haven't gone across all the power rails, but none of the 1.8 volts are there. None of the 3.3 volts are there. I think I've seen 5 volt somewhere. No, I'm not sure. No, do you know what? I don't even think I've seen the 5 volt. So, I mean, it could be this chip here, because I think this is generating the 5 volts and the 3.3 volts. Annoyingly, when I go through the schematics, they're not in order. I thought it would have just kind of been where, you know, in order. It's not. It just seems to be all over the place. So I don't even think the 5 volts here. But look, I mean, I'm not making this up. This is fully short into ground, isn't it? Yeah? And this shouldn't be on ground. That inductor there on the schematics, it's not connected to ground. So I'm still confused why my bench power supply is not showing anything up. So what I'm going to use is, because as far as I'm concerned, that's a fault there. I bought this ages ago. I was told about this. I also seen it on North Ridge Fixes video. I had to buy it from China. At the time, they weren't selling it in the UK. It's a short circuit detector. Now, it shouldn't do anything different than this, but I don't know what was going on there because my leads were just heating up. I think it's just because it's a dead short. Is it easier just to go straight through the leads and back again? I mean, it should be still going through the circuit. I don't know what's going on. Unless, of course, there's something dissipating it really well. Let's just say if somehow, although it's here, if somehow the short is under the CPU, or I don't know if this is a GPU, if the short was there, is it being dissipated through here and that's why I'm not feeling it? And it's just showing up on the leads. But anyway, I'm going to give this a go. The only problem is I bought it months and months and months ago, and when I've gone to use it, the batteries are completely flat. Even though I did charge it when I got it and I haven't used it, the batteries have gone flat in the meantime. So it's been charging up for about 10 minutes now. I'm hoping that's going to be enough. I think it goes all the way to 20 something amps on this, and you can select the voltages as well. So let me show it to you. I don't know if it's any good or not, but let's give it a go just in case that picks up the problem, although my power supply doesn't. Get my IPA at the ready. Right, so there's this little thing here, and look, we have voltage selection at the side. So let's keep it at 1.2 volts, which is that one there. Let's plug this in, turn it on, 1.2 volts. So when we go to here, it should now be putting 1.2 volts out. So let's just see if it is. .2, yeah. So let's turn that off there. Let's do this and see now if something heats up differently than when I was messing with it before. So we're on there, yeah? We're making a nice contact there on that ground. Now turn it on and let's go on to, well, I can just go straight onto here. It's gone off. Is that because the battery's flat? Thing is, if you're using it every day, fair enough, but I wonder, can I power it while using the USB? Can I use it while doing this, I wonder? Yes, hopefully I can. Okay, here we go. Now, what I was going to say is it's fine if you're using it every day, but if you're only going to use it once every couple of months and it's flat when you go to use it, that would be a bit annoying. And what does that mean? What does that mean? What is going on here? So it's fine there, yeah, because there's no short there, but when I go to use it here, it's cutting out. Is it just because the battery's not powerful enough? Okay, let me leave it charge up. Well, I still don't know what the problem is, but I put the coil back on, this one here, because I was looking online and Lewis Rossman's done a video where he also had this same board, No water damage or anything, looked perfect, just like this one here. And he was having 5 volts, I think it was at 0.3 off an amp, I know mine's a bit higher. And on his one it was DFU. It was basically DFU after some update that had mucked it up. So I'm going to put this back together. I'm going to connect it to, see look, it's gone to what it was, 0.3 there. I'm going to connect it to my other Mac. You've got to use a certain port. You've got to use USB to USB-C, sorry, USB-C to USB-C. And I'm going to load up Apple Configurator 2 on the working Mac and see whether or not this is coming up as DFU. Well, unfortunately, it's not working. So this is the Apple configurator here, and when I do the key combo here, it's not working. I've got it in the front port. It's connected to that MacBook there that's running it. And if I do, well, you're not going to be able to see me do it. Let me just do it from here. So I've got to hold down the power button and then shift, control and option. Power button first for 1 second, and then the others for altogether for 10 seconds. So 1, 1000, 2, 1000, 3, 4, 5, 6, 7, 8, 9, 10, and nothing's come up on the screen up here. You see, it's completely dead. As well as that, if you have a look here, look how low it's charging now. Can you see? Yet when I unplug this one, watch it jump up. Ready? So here we go, unplugging it now. You see it jumps up, and every time I plug it in, it goes back down. It doesn't matter what port I go into. So you can see that, yeah, that's a bit odd as well. But maybe that's normal, you know, because I've got power and then I'm trying to connect another Apple MacBook into it. So I'm going to take it apart again. I think the only thing I can do is start removing capacitors on that rail to see if I can trace the fault further. I think it's going to be a chip-related fault, you know. Right, now there's lots to get through. It's going to take me ages. There's even more than this, but these are the kind of main ones. But then that rail goes off to feed other rails as well. So I don't really think this is doable. But what I'm going to do is I'm going to start with the bigger capacitors anyway. I'm going to take one off, quickly check it, put it back on. Take the next one off, quickly check it, put it back on. Because if I take them all off, I'm going to struggle to get them back on in the right order. And you never know, I might get lucky. It might happen on the first few capacitors, which would be nice. Well, let me just keep you updated about what's happening here. Now, I've taken off easily 15 components on that line there, and it made no difference at all. The short is still there. So basically, I took off all these components down here. There was the capacitors in the middle here. Then I moved along that component up above there, the little capacitors there, then also these two capacitors here. I took off 2 of the chips here, which are also feeding it, capacitors around it. It made no difference, the short is still there. Now, I spoke to Paul Daniels, he's been really helpful. I've been telling him about this fault here. And the reason this here, the bench power supply, just the leads were heating up, is because the resistance of the leads is more than the resistance in the board. So the leads are going to heat up more. So what he suggested is use shorter leads or thicker leads. So what I've done is I've wired up these 2 bits of cable. I mean, this is, from memory, this is 2.5mm cable from a main supply, you know, 240 volts. And I've put that straight into my meter here, so the leads are absolutely tiny. I've got my meter butted right up against it, and all that's happening is it goes straight to 10 amps, which is the max this meter will do, and only 0.4 volts. So what I've seen before when I got it up to like 1 point something volts is because of the leads. When I do it like this, it doesn't make a difference. If I up the voltage even more than that, it still makes no difference. It just jumps straight to 10 amps. So I can't really get, but the thing is, this is heating up. You know, there's still, I can still feel a little bit of heat in the leads here. So you would think even at 0.4 volts, well, it was 0.44 volts at 10 amps, that is going to be 4.4 watts. Is that right? I think so, yeah. So you would still think that if a capacitor was shorted, that it would heat up. Now, I had it on there for about half an hour. My power supply was cutting in and cutting out. You know, the fan was kicking in and kicking out. So there was definitely heat being generated. And I couldn't find any heat on the board whatsoever. Now, I haven't got a FLIR cam to check for heat, but I went over with the back of my hands. I know this is sad. I even went along with my lips, the bottom of my lip just touching against the different parts here. I don't recommend that, but I just wanted to see because it's more sensitive. I went on both sides of the boards. I couldn't find any heat at all. The only heat being generated is the heat coming from the leads. So wherever I attach the leads, that's where the heat is being generated. Now, I checked out my little mechanic thing here. When I go across a resistor here, this is working. You know, it's drawing whatever it is. I can't remember now, 50 milliamps or 50 I can't remember, 50 milliamps, and as I up the voltage I think it goes to 100 and something milliamps. So this is working. It's just that it's got a protection mode where when you short the leads together, it kicks it out and then you have to hit both buttons to reset it. So this short here, because it's a complete short, like a full-on short, it's the same as having my leads together, it is kicking this meter out. So unfortunately, I'm not really going to be able to take this any further because there's a short somewhere on here and I can't find it, but I don't believe it's coming from a component. In the back of my mind, I thought, has it shorted internally? And that's exactly what Paul Daniels says can occur on this particular design of boards. So I'm thinking, although everything looks perfect and I can't see any bulging or anything on the boards, I'm wondering if there is an internal short somewhere. I would have thought that that would have manifested itself in some kind of like burn damage somewhere, but maybe not. Maybe not. If it's more to do with flexing, if it's been flexing and broke, then maybe it's just going to be shorting against something without causing a catastrophic burn somewhere. Anyway, what I'm going to do is I'm going to look through the schematics. So for example, I took off this coil here, the inductor here, and now I know that this bottom pad is okay because that's in the 1000 ohms and this top pad is where the short is. So if I was to then go further into the circuit and maybe take off more inductors, I might be able to narrow it down to, for example, 30 components. Do you see what I mean? Because at the moment there's hundreds of components on all this the 3.3 rail going forward. And I'm going to see where this one feeds and then to see if I can disconnect each of the different rails that this one feeds by taking off maybe a smaller chip or an inductor, and then that might kind of isolate it more down to a smaller area. But yeah, a real shame. I thought I was going to get this one working when I seen the short, but no such luck. Anyway, when I have more info I'll start filming again. Right, now this is interesting. I'm still nowhere near fixing it. This one won't be fixed, I'm sure of that now. But I've removed all these, like the big capacitors, some of the small ones, I've removed that. I've removed these. I've checked the resistors and I haven't done them yet. But anyway, I was thinking this is silly. There has to be a way that you can test for a short to ground when it's coming up everywhere. So I was watching a video by Grant's Past TV Repair, and he uses millivolts to try to pinpoint the exact problem. I've got my lead set to 0.9 of a volt and unlimited amps. So on this is going to be 10. It's going to be 10 amps. Now let's go on to the positive here and the negative here, and you can see at this moment in time it is drawing 0.9 and it's drawing 4 amps. Yeah, the reason it's drawing that much now is because of these leads. because they're so thin. If I was to put this straight onto here, it would go straight up to 10 amps and it would only be drawing 0.44 of a volt. But anyway, check this out now. So let's go over to this capacitor over here. So again, using a ground. And if I was to go onto these capacitors here, you can see that they're reading 55. Yeah? If I was to go onto this capacitor here, you can see it's reading 56. If I was to go down here, onto this rail down here, which is still the same rail, you can see we're reading 74, so we're a little bit further away. So in theory, these are further from the fault. Let's go to, just to show you a different ground on the same one here. Again, you see, same reading. Now let's go on to these ones. And you can now see 16. So that says to me we're closer to the fault than we were before. Now, check this out. You know the capacitors up here, so we've got 41 there. Keep the same ground there and go over to here and look what we have. 0.8. Let's take a different ground and go onto here. 0.4 and 0.4, and over here, oops, sorry, that side, that was the ground side, 42. Do you see what I mean? And if I go onto the ground side of the capacitors, you can see it's reading much different. So although our meter's showing a dead short, can you see there is a difference? So that says to me, instead of removing these caps here, it would be better to remove these caps here. Sorry, it's the top ones. Do you see what I'm getting at? Right, while I'm editing this back, I'm thinking, am I actually making much sense here? So let me just do a quick voiceover. Basically, the lower the reading, the closer the fault should be. So what I was getting at is, on the ohms reading, I couldn't really tell if the fault was on the right-hand side of the board or the left-hand side of the board. But by doing this millivolt test here, you can see that the lower reading is coming from the left-hand side of the board compared to the right-hand side. So it would be better to look at the components around the left-hand side where you have the lower readings, because chances are that's going to be closer to the actual fault, the contact with ground, than the other side. So now, I know the video's already been going on for ages. I've spent hours on this so far. And this next part here takes me hours as well. What I'm doing is I'm taking readings all over the board to try to work out the best components to take off, because I can't take off over 1,000 components. It's just not going to happen. So yeah, I'm bit by bit taking off more and more components, doing more and more measuring, taking off more and more components, and doing more and more measuring. Eventually we start to make a little bit of progress. Let's pick up the video now. Right, progress has been made. The hours are slowly slipping by, but check this out. It's still not working. I don't think it will be working, but remember the massive short we had here before? Don't know why I'm building it up, because you know it's gone. Look at that. In the mega ohms. Yeah. So now, this particular rail, as far as I can see, is now testing okay. PP3V3 underscore G3 hot underscore T. But we still have the full-on short on this one here. PP3V3 underscore G3 hot underscore RTC underscore X. So I had to basically find all the places where this met here. If I'm honest with you, I don't know if this makes this or this makes this. I would think that this makes this, but I'm not too sure. It's so confusing on the schematics and stuff, because sometimes out will be on the right hand side, sometimes out I think can be on the left hand side. I'm really struggling with it. But basically every place that these two met, I had to take off the components, and I've had to take off quite a few components to get here. You can see them all dotted up here, little kind of regulators. The one chip that it finally went on was all the way down here. I think from memory I had to slide the capacitor over, and when I took off this chip it then cleared the first rail, but not the second rail, not the RTC rail. So if you have a look here now, we still have the full-on short, so obviously it's still not going to work. We still have the full-on short on these little kind of fuse link resistors here. here, over here. So if I was to go to a ground here and go on to these little ones here, you can hear my meter going. In fact, let's take it off continuity and go on here. You will still see that we will have that complete short going on there. Yeah. So now I need to start breaking down this one here. I've already started to break it down because I've taken off a component over here which goes on to feed this chip, and the short's still there. But anyway, I'm going to keep going until I have an answer, I hope. If not, it'll be a revisit video. Oh, MacBook, why have you taken so much hours out of my life? Right, I have been working on this for, even up to that last part of the video, I was working on it for hours upon hours. I've actually been on it for days since then. Well, maybe not days full time, you know, but many hours. Now, let me just fill you in. It's not going to work, and I don't even think I'm going to get a revisit video out of it, but some interesting stuff has happened. I've managed to get it up to 20 volts. So let me just tell you what I've done, because there's just far too much footage, and also then I stopped filming after the second or third day. But anyway, what I was doing is, remember now we had a big old short on this component here. A complete short to ground. Well, I was working my way through, tracing it, and eventually I worked out that if I disconnected those two sort of 0 ohm resistors there, that would break the circuit between here and also the next rail, which ends in RTC. And then when I disconnected them from here, this no longer had a short on. This was in the thousands of ohms, so that was all good. And the short was then on to the pads here, going more into the boards. Now, the rail here goes on to feed so many different things. So I couldn't take off like the big chips like this and stuff, but yet I could take off where it was meeting resistors and smaller voltage regulators and stuff. I was taking them all off and it wasn't getting rid of the short. So then I thought, okay, I'm going to put voltage into it again. This time when I put voltage in, because I was no longer connected to this, it did actually draw more. Before I think it was 0.44 volts at 10 amps. This time it went up to about, I think, 0.8 volts or 0.9 volts. Anyway, a lot more wattage was going into the board, and basically this whole area here, all across here, was getting warm. Yeah, so nothing here. This was all ice cold. This was all ice cold. Over here was all ice cold. All the heat was being generated in this area here. Now, I left it on there for ages, and I thought most of the heat seemed to be coming from this area. Now, that is like the power management chip type thing that did actually go 40 in the 2020 MacBook Air. But it wasn't a pinpoint. It wasn't kind of coming from a corner and spreading. It was just this whole area here that seemed to be heating up. But I couldn't really swear by it because the whole area across here was warm. But this area here to me seemed to be warmer than the other areas and seemed to get warmer quicker when I disconnected it and connected it up again. So I thought, right, okay, I'll remove the chip. So I removed it, and then as soon as I removed it, the short went away from the board. But that doesn't necessarily mean that that chip is faulty, because that could be connecting up that rail to loads of different rails, and all that could be happening there is I've disconnected a faulty rail that it was going onto. But anyway, I thought maybe that chip is faulty. So what I did is I ordered some up from China, but unfortunately they're not going to arrive until April was the estimated time, and I was getting impatient. Now, that particular chip is also on another water damage board that I've got on a 2020 MacBook Air, the pink one that's all rose gold, that is water damage, so I took it off that one. Now, I did get a stencil to try to stencil the balls onto it, but the stencil's kind of quite floppy, and all that happened was when I was putting the solder paste in there, the solder paste was going through the holes onto the chip and just spreading around the place. So when I added heat, there was just a mess. It was just a mess of solder. So what I did is I took the solder off the board and the chip, and then I just put a blob of solder on the end of my soldering iron, and I rubbed it across the chip and I rubbed it across the board, making sure that every single ball or spot or pad had a little bit of solder on. Obviously it's not the same as reballing, but between having some on the chip and also the board, I was hoping that they might marry up. The problem is there's 324, I think it is, balls underneath here, so you can imagine it's not a simple thing to do. Anyway, I put a different chip on there, and sure enough, the short had gone from here, and I thought, oh, brilliant. But then when I plugged it all back in, this area here, this RTC rail should have 3.3 volts. It was only having 1.1 volts. I thought, well, that's not right, that's being dragged down. So then I turned my attention to this, and I noticed that this chip here, which I think is the SSD, so I think we've got one here, the other side of the board, and also two here. I'm not sure if we've got some on the other side of the board as well. And this was getting warm. Not this side, but this side was getting warm down in this corner. So I thought to myself, oh, that's interesting. And then what I did is I measured where the voltage this was getting fed from, and it looks to be getting fed from this chip. And there was inductors here. There was 3 inductors, 1, 2, and 3. Put the third one back on because it didn't make a difference. But when I took these two off, these two are linked to each other. When I took them off, I all of a sudden had 3.3 volts here. I all of a sudden had 3.3 volts here. And I seem to have more working on the board. So basically, if I was to put the inductors back on here, this here will get warm, this SSD will get warm, and then this is stuck at 5 volts. But now watch this, when I plug this in now, we have 20 volts, but it's not drawing any amps. See, we've got 20 volts now. I have got the battery and everything connected, so everything's connected. But yeah, 20 volts, but it's not turning on, it's not doing anything. Then I thought to myself, right, okay, how about if I make my own voltage rail going into it? So what the worrying thing is, on these pads here right now, there will be 3.3 volts. But this should be 1.8 volt and 0.9 volts going into here. So I'm wondering if this little chip here has failed and it's trying to push 3.3 volts through to here. In fact, let me get the multimeter just to show you that. Now, I'm doing this one-handed, everything's balanced, but look, if I put my probe to here and go here, you can see 3.3 volts. And if I go to, I think it's that one, yeah, 3.3 volts. Yeah, but annoyingly, this one here should be 1.8 volts, and it's coming up as nothing. So I've only got the one bench power supply that I can limit the current on. But what I thought is, how about if I put my own 0.9 volts into there? So that's what I've been doing. So I've been turning this on here. You can see we've got 0.9 volts, and I've got a little lead soldered on to where the inductor would be. And now if I put this one onto here, you can see that it is drawing 0.4 of an amp, but yet there's still no different current draw on this thing here, and also it doesn't turn on. And I've been trying to do the DFU as well, you know, the DFU where you plug it into the front USB port. So I had this over this side here, I was using the front USB port. Nothing's being recognised at all, it doesn't come up as DFU. So basically that's where I've got now. I think it's a problem with the SSD, but I don't know whether the original problem was the SSD or not. Maybe because it took a couple of attempts for me to get this on, maybe on the first attempt something was shorted in here and sent the wrong voltage through to here, or maybe the wrong voltage through to here, which then put the wrong voltage through to here. I'm not too sure. Maybe this is the thing that's failed and it's trying to shove 3.3 volts into these lines that should be 1.8 volts and 0.9 volts, because we haven't got 1.8 volts on this one here. But basically, I kind of feel that I've taken this as far as I can take it, because I've been on it for days and days and days, and I'm just going around in circles. It might be easy if I had another board to take measurements against, but I haven't got another board of this exact same model. And you know what? It's so complicated. It's even hard to try to follow the power rails because they just seem to be all over the place. You know, there doesn't seem to be a sequence of things I can follow. It's seriously, seriously complicated. So, yeah, I'm going to call it a day at that. At least we got 20 volts in the end, which is nice, but it's not drawing anything whatsoever. If I was to put the inductor back in there, in fact, if you want, I can do that now. 1 second. I've got the inductor under my finger here, just using pressure to put it down, and you can see that it's 5 volts. Yes, it's at 0.5 of an amp, but it's dropped to 5 volts and it doesn't move up from there. And then if I was to take it off, it's going to be stuck to my finger. There we go. This is it here, and you'll see it will go off and it will probably come back on as 20. No, 5 volts. Is it going to come back on as 20? 1 second now. Off. Back in again. Yeah, there you go, 20 volts. So yeah, real weird one. It's unfortunately it's way too complicated for me. I'm completely and utterly lost. Now, a massive thanks to Paul Daniels for helping me on this. I have had help via emails. If anybody's got any idea about maybe what it could be, if you could possibly put it down in the description below. I know it's very hard because I haven't taken you through the full journey, because it's just been impossible to make into a video because I've just spent too long on it. But if you've got an idea, maybe what could be causing, you know, this when we have the 3.3 volt rail, but yet when it goes through to here it drops to 1.1. Is it likely that the SSDs fail? Remember, this board had no water damage or anything. It was immaculate. It looks like it just failed. So maybe the SSDs were the problem in the first instance, because these ones here do not get warm, but yet this side and the other side do. So yeah. So apologies I couldn't get it working. I did honestly try my very, very best. Hopefully you got a slight bit of entertainment from it, and all I can say is that when it comes to MacBooks, they're incredibly complicated. But yeah, I think I'm going to go find myself a Tomy toy and try to fix that instead. Might be able to get my head around it more. Anyway, until the next time, take care everyone, and I will see you all very soon. Thanks for watching.